All right, here we go. You ready for something that's a little more complicated? Let's try this one. Let's do n factorial divided by n minus 2 factorial. Well, we don't really know what n is. It's just some number, but we know that this is going to equal that number times 1 less than that. So that would be n minus 1, and then n minus 2, and then n minus 3, and this will just keep on going. And I'm going to divide that by, let's see, I'm starting here at n minus 2. Again, I don't know what that number is, but whatever it is, I want 1 less than that. So I got to subtract 1 more, so the next factor would be n minus 3. And then n minus 4. I'm not going to write that. I'm going to go dot, dot, dot. And the reason is because the n minus 4 here and the n minus 4 here, those will cancel. And then the n minus 5s cancel. This thing will just keep on going until it gets down to 1. I don't know how long that takes because I don't know what n is. But I do know that this cancels with this cancels with this. Whatever's next will cancel, whatever's next after that, all the way down to the ones. And so what that means is I'm only left with 2 factors, and so this answer is going to be n times n minus 1, which is n squared minus n. There's my answer to that problem. You guys go ahead and try this one. This time I've got n plus 3 factorial times n plus 1 factorial. Again, every time I say you guys go ahead and try this, hit the pause button on your computer, try the problem, and when you're ready, start it up again. All right, so I'm starting at n plus 3. My next factor would be 1 less than that, which would be n plus 2. And then n plus 1. Subtract 1 from that, you would get just n. And then n minus 1, and this will just keep on going. In the denominator, I start with n plus 1. Subtract 1 from that, you get n. My next factor would be n minus 1. And I'm going to stop there because that's where I stopped in the numerator. Dot, dot, dot. So the n plus 1s will cancel, the n's will cancel, the n minus 1s will cancel, and here's what I'm left with, so I just need to multiply that out. N plus 3 times n plus 2. If I FOIL this, I'm going to get n squared plus 2n plus 3n, add those together, you get 5n, and then plus 6. There's my answer. Okay, that's our first type of problem. The second type that we're going to do for today involves this symbol. And this is a Greek letter, it's the Greek letter sigma. And whenever we see this, it means summation. So what we have is some numbers that we have to add together. And when you use that symbol, the problem will look like this. It's called the summation for I equals 1 to 4 of I squared times I plus 1. So let me say that again just so we understand how to pronounce this. It's the summation for I equals 1 to 4 of I squared times I plus 1. Now, when you do a problem like this, this I is a counter, and it counts by integer values. There's no decimals, there's no fractions. First I equals 1, then it's going to be 2, and then 3, until we get to 4. And once we get to 4, we stop. So the top number here is telling us what the stopping point is. And the idea is that you take the first number and you plug it in. So I'm going to plug a 1 in right here. 1 squared is 1. I'll put a 1 here. 1 plus 1 is 2. And that was for I equals 1. Now I have to do this again when I equals 2, and I'm going to add those together. So if I plug in a 2, I'm going to get 4. Plug a 2 here, you get 2 plus 1, that's 3. I'll have to figure out what that is. And then I'm going to let I equal 3. So if you square that, you get 9. 3 plus 1 is 4. And then the last number I plug in is 4. So 4 squared is 16. 4 plus 1 is 5. Now I have to figure out what each of those answers is going to be and then add all those together. So 1 times 2, that's 2. 4 times 3, that's 12. 9 times 4 is 36. And 16 times 5, let's see, that'd be 50 plus 30, that's 80. And now we just add those up. So I've got 14. Add it to this, I would get 50 plus 80, that's 130. And there's my answer. You can imagine if this would have said the summation for I equals 1 to 400, that's a long problem. That would take a while to do. But that little kid in the elementary classroom, he figured out easy ways to do this. And eventually we're going to get to those. Let me give you guys one to try. Let's see, I believe I'm on number, let's see, this was 6. I think I'm now on 7. So we've got the summation for n equals 5 to 8 of 2n squared over n minus 1. So we don't have to use the variable I, and we don't always have to start at 1. We can start anywhere we want. So this time I'm going to plug in a 5, and then a 6, and then a 7, and we'll stop when we get to 8. You guys go ahead and try this. Alright, so if I start with a 5 and I plug that in, I'm going to do 5 squared, which is 25, times 2, that's 50, over 5 minus 1, that's 4. And I'll reduce that in a minute. Plus, now I'll let n equal 6. So 6 squared is 36, times 2, that's 72, over 6 minus 1, that's 5, plus, now let n equal 7. 7 squared is 49, times 2, that's 98, over 7 minus 1, that's 6. Looks like that can be reduced. Plus, now I'll plug in an 8. So 8 squared is 64. Times 2, that's 128. Over 8 minus 1, that's 7. And so what I have here is 4 fractions that I need to add together. And I think I'll use the calculator to do that. So I've got, and even though this hasn't been reduced, that's okay. 50 divided by 4 plus 72 over 5 plus 98 over 6 plus 128 over 7. And when I hit enter, I'm going to see a decimal answer, but remember under the math button we have that convert to fraction option. You can go ahead and do that, and there's our reduced answer for adding these together. So what I have is 12,919 over 210. There's our answer. If you don't have your calculator at home with you, there's always calculators on the computer you can use, but something to make that a little bit easier. Let's try one more of these. This time I've got the summation for k equals 3 to 7 of k squared plus 2k minus 3. You go ahead and try it. All right, so I want to start with a 3. I'll plug that in. I'm going to get 3 squared, which is 9. 2 times 3 is 6, minus 3. There's my first k value that I'm plugging in. And then I'll plug in a 4. Remember, it's summation, so we have to add all these answers together. So if I plug in a 4, I'm going to get 4 squared is 16. 2 times 4 is 8, minus 3. Plus, now I'm going to plug in a 5. So I'm going to get 5 squared, that's 25. 2 times 5 is 10, minus 3. Plus, now I'll plug in a 6. 6 squared is 36. 2 times 6 is 12, minus 3. And the last number I need to plug in is 7. So I'm going to get 49. 2 times 7 is 14, and then minus 3. So now I'll figure out the answer for each set of parentheses. I've got 9 plus 6, that's 15, minus 3, that's 12. Here I've got 16 plus 8, that's 24. Minus 3, that's 21. Over here I've got 25 plus 10, that's 35. Minus 3, that's 32. Add these, I get 48. Minus 3, that's 45. And then 49 plus 14, that would be, let's see, 63. Minus 3, that would be 60. And now if I add those up, I'll go ahead and use the calculator to do that. I've got 12 plus 21 plus 32 plus 45 plus 60. 170 is my final answer. That's it. That's what we have for today. So, these assignments, we're not grading them, we're not turning them in. This is really just us doing some work to try and keep our skills up and make sure that things that we're supposed to learn this year that we need for next year, we've got that down. So I'm just going to call this C1, Coronavirus First Assignment. I don't know what else to call it. And that assignment is going to be on page 650 in our book. We're going to do 67 to 82. There it is.